thing you learned something. At the top of this paper, write down the term isometry. You might see different versions of this word. It might be isomorphic. It might be isometry. It might be a plural, isometries. What we're referring to, at least this year, are reflections, rotations, and translations. When we look at reflections, rotations, translations, the common factor is that there is no size change. The before and after is the same size. What's another way of saying that it's the same? What term have we been using? Congruent. It's congruent. It's not in the same exact spot. It might not be in the same orientation, but it's congruent to the original shape. How many of you have seen the tick mark before? It's a copy. How do you pronounce that? Prime. Prime. So from next to the Sarah, let's write down the phrase K prime. We don't say K tick mark. We say K prime. Why is that important? That tells you where your start and finish are. I know now that this is the starting figure, and the one with the prime tick marks is where we finish up. That's the end result. Naturally, in math, we don't use start and finish. That would be too easy. We use pre-image, and up here, image. Those are our technical terms.
Wow.
Raise your hand, tell me what your answer is to that start and finish, that pre-image and image. Kirsten? See? Let's take a look. If I have x minus 3 and y plus 5, what that is telling me is that I am moving left 3. So someplace up here we could write down left 3 and plus 5, up 5. Does it look like I am moving this way 3 and then up 5? Can I count units? 1, 2, 3, 1, 2, 3, 4, 5. I'm going from K to K prime. That set of directions will work for every single point within the figure. So if I go to W and want to get to W prime, it should be left 3, up 5. This notation, where we have x, y, and then we have an arrow, and then we have the x minus 3, y plus 5. The first part is the pre-image. The arrow in this case doesn't represent if-then, like it did back in chapter 2. This time it stands for transformation. Something is happening. Something is being changed. The second part is what we call the image. And it's indicating what's happening to every single point in the pre-image. Every single point in the pre-image is being moved 3 to the left and then 5 up. based on the -3 and the +5. When you see addition and subtraction happening within a formula like this, you know that you're looking at a translation. What's a more informal way of saying that you have a translation? It's a slide. Has the figure changed size? No, so it is a what? Not only is it a transformation, it is a isometry. All isometries are transformations, not all transformations are isometries. Number 2. Raise your hand. Tell me what you have for an answer for number 2. Tim. He's got B. Most people know that this looks like a flip. That's our short term for a reflection. But they might not know that the reflecting line, let's put an arrow there, the reflecting line can be represented with what you learned in algebra. We could have a y equals mx plus b reflecting line. But in this case, it happens to be vertical. So what do vertical and horizontal equations of lines look like? They look like this. They have one variable. You could have equations that are y equal to some number, and those would be horizontal. You have to think back to your algebra now. X equals 1 is the name of that line. It's going through the x-axis at 1. Could everybody tell that this was probably a flip and not a rotation?
Yes.
If you have multiple choice in front of you on a test, go ahead, reduce your choices. We can at least get rid of the rotation. When I am looking at a possible rotation, I start thinking of the flag. What shape is the flag itself? Rectangle. But what is connecting the flag itself to the wall? The pole. I refer to it as a handle. This is how I visualize rotations. We are rotating, it looks like, around the origin. So let's put a dot right in the middle. Think of this first shape, the one without the tick marks, the one without the primes, as a flag. We are going to rotate that flag. So it needs a handle. I'm going to connect the handle to my center turning point. So imagine that that's the handle, and I'm going to turn it. Where is R going to end up? What are we going to call it? R prime, right? So that's where the new handle should be. Let's draw another handle over to here. So I turned it from here to here. What is the angle between the handles?
Oh, wow.
That's how I visualize it. You probably won't see that in a textbook. It helps me to visualize what's going on. Which one is the end result? Which one is the image? The prime. So it went this way. Which way is that? Clockwise. So that matches up with B. It's 90 degrees. If it was 180 degrees, then I'd have to turn the handle 90 more degrees, and that's not what is happening.
Wait. Oh, can you explain that again?
I took the flag. I want to rotate this flag from here over to here.
Wait a minute. Wait a minute.
Pretend that this is the flag, and I just make a handle on it. The flag isn't rectangular in this case, but I know that R ends up where R prime is. Right? Does R correspond to R prime? So the handle is still attached to R. I look to see the change in the handle. The change in the handle is 90 degrees, so the entire rotation is 90 degrees. We're going to be doing more of these. Every single day, the first half hour is transformation. So we'll be doing a whole worksheet just on rotation. And you'll see another example of that. Number 4. What can you probably rule out right away? Probably rotation, especially if it's about the origin. If it's around the origin, it should still be the same distance away from the origin. That doesn't make sense. This is our pre-image. This is our result, the image. So I'm starting here, I'm moving to, in which case this is a blue figure on my diagram, probably not on yours. Is it moving left or right? Would that indicate addition or subtraction?
Addition.
Well, that doesn't help me because they're all addition. How about up or down? Which one of these includes subtraction down? So I know not that. Which one is the correct answer? B. Take 1 point and test it out. You're moving over 1, 2, 3, 4, 5, and then down 1. Over 5, down 1. This is another slide. Every point, since we didn't change size here, is going to be moved the same way. Pre-image, image. Next page. Since the orientation of this has changed, M was at the bottom. Now in this figure, M is at the top. So either we've got a reflection going on or a rotation. A translation, the orientation would still remain the same. So I'm going to cross these two out. If this was a reflection, the E would remain on this side. Where does it end up? Over there. So this is probably a rotation. Let's check using my handle method. Go to the origin. Which is our pre-image, M or M prime?
M.
Let's connect it. Make a handle. I'm going to turn this until my handle ends up at M prime. How many degrees have I moved the handle?
Oh my God.
180 degrees. Half circle.
Wow.
What's our short word for a rotation?
Turn.
We have flips, we have slides, we have turns. That's just for you to know. Since the orientation looks like it changes, here N is at the bottom of the figure, and then in the new figure N is at the top. This is probably not a translation. Let's check to verify that it's a reflection across the x-axis. Darken in the x-axis. And darken in the pre-image. Let's darken in this right here. We want to focus on the original image. If the reflecting line is actually going through the figure, then some of the points are going to flip to one side, and the other points are going to flip to the other side. So which 2 points are on the top here? What is this and this? G and M. They're above. Where are they going to flip to? That's where they end up, right here and here. What are these two? We got N and X. They're below. Where are they going to flip to? Up top. That's where they end up. So you get an overlap when your reflecting line is going right through the figure. Whatever's on the left moves to the right. Whatever's on the right moves to the left. Up, down, down, moves up. We will do an entire worksheet on reflections to show exactly how you would do that. But can you see that that's not a slide? Some of the problems will be this easy. Other problems require a little more work with our coordinates. Question 7. What's your hunch as to what this is?
A rotation.
Looks like a rotation. If it was a slide, the orientation wouldn't change that much. So let's get rid of that. Make a handle.
Oh my God.
Here's a handle. Let's do it to D. Imagine that the triangle is a pennant or a flag. And we're ending up at the primes. It's moving this way. Clockwise or counterclockwise? This is counterclockwise. So maybe it's this. Let's see if we have the right angle. If I'm putting my handle to D, where is the new handle going to end up? D prime. What's the angle in between? Remember that D prime, G prime, and H prime are the end result, the image. This is your pre-image. This is your image. What we will take a look at later on down the road is what happens to those points. We don't just add and subtract to get to the new points. We have to do something different. Number 8. We are starting off here. We are ending up this way. What can I rule out? Reflection. Is it just moving horizontally, or is it moving both horizontally and vertically? Take a look. F moves over 1, up 1. Over 1, up 1. What's the word for translation? Slide. Slide. What's the rule? What's the word for a rotation? Turn. And flip. 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 Or a... That's the basics. That's probably 60% of what you need to know. I did not get a chance to grade the dilations, but we're going to go over those right now.